Here we're looking at example 10 from our 1.5 number 2 set of notes. We're asked to evaluate the following limit as x approaches infinity of this guy. Now, if you were to try and use that direct evaluation, you would end up with an infinity minus infinity, and unfortunately, that is a type of indeterminate form, so we can't actually use that because we can't, again, really identify where that limit's going to. Now, another opportunity that we can do is something using algebra. So we know that we have this entire thing is really the same thing as saying the same thing over 1. And what we're going to do is we're going to go ahead and multiply the conjugate on top and bottom. So the conjugate of this comes out to be x squared minus 3x, so we just pretty much rewrite the same exact inside. Instead of a negative here, we're going to go ahead and change that to a positive. And then we also have our x. So we're multiplying the entire conjugate on top and bottom, because essentially this is our FFU move. Now this is, again, another major strategy that we see, especially a lot with limits. Now going ahead and foiling this, we have this first piece times itself. Well, essentially, you have a square root, and you're multiplying it by itself. And as a result, you are essentially basically squaring it, and you're left then with what was just underneath. Now I'm going to go ahead and just show the process so you guys can actually see it. But essentially, we have the square root of x squared minus 3x. And because we're multiplying it by itself, you are essentially squaring that. When we do our outside, we end up with plus x times the square root of x squared minus 3x. And then when we FOIL the inside, we end up with minus x times the square root of x squared minus 3x. And then when we do our last, we end up with minus x squared. On the bottom, we're actually going to just leave him alone. So really we have 1 times this piece, the square root of x squared minus 3x plus x. A lot of times, though, there are some other items in here, but typically we actually want to leave him undistributed on the bottom. So we end up then with still x, the square root of x squared minus 3x plus x. And the reason why I wanted to show every step is just to really show you the power behind multiplying by a conjugate like we did up here. As you guys can see, we still have the limit as x goes to infinity. And we have something that has this square root that's being squared. So again, those are inverses of one another and will actually be canceled out with one another. And then you're left with what was just underneath, this x squared minus 3x. Now we have a positive x square root of x squared minus 3x and a negative x square root of x squared minus 3x. So because those are opposites of one another and are exactly the same, they'll just cancel out. And you'll actually see that happen all the time when you do your conjugates like that. And then the last piece is just negative x squared. On the bottom, we have our square root of x squared minus 3x plus x. And then we can do even a little bit further simplifying where our x squareds actually cancel out on top. Now this is equal then to the limit as x goes to infinity of negative 3x on top over the square root of x squared minus 3x and then plus x. Now, if you're thinking at this point, well, can I use my direct evaluation? I saw some canceling happen there. I don't have any more square roots on top. Well, let's go ahead and try maybe using our direct evaluation. If you throw infinity in here, you end up with negative infinity. On the bottom, if you throw infinity in here, you end up with infinity just from this part plus infinity. Well, again, that is an indeterminate form. Alone, just even on the bottom, but let's just say for giggles it was infinity. Now you're ending up with another indeterminate form. So unfortunately we still can't use direct evaluation. We now have to then maybe do a little bit more algebra to actually break this down even further. And as a result, we're actually going to use now our FFU move. So we're actually going to divide the top and bottom both by, if you look carefully at the degree on the bottom, we notice that it is actually x to the 1. It actually does show up here as well when you see the square root of x squared. But it's essentially the highest degree on the bottom is x to the first. So we're actually going to divide the top by x and the bottom by x. And as a result, we end up then with the limit as x goes to infinity of negative 3x on top over, dividing it now by x, all over the square root of x squared minus 3x. Well, again, when you're dividing by just x, that's the exact same thing as saying the square root of x squared. So as a result, instead of us dividing it by x, we're actually going to replace it with this x squared plus x, and again, we're dividing this bottom by x. Now again, the reason why we could do that move is x is really the same thing as saying the square root of x squared. You could even check, notice they are inverses of one another and cancel. So you can actually do that move where you just throw in the square root of x squared on the bottom. So just simplifying things even further, we end up with these x's actually dropping out, leaving us with negative 3 on top over square root. Just looking at this first piece, x squared divided by x squared is just 1. This piece will just come out to be minus 3 over x, because one of the x's would drop out, and leaving you with 1 left on the bottom. Plus, x divided by x is just 1. So now notice, this is a lot more manageable in terms of actually our values. We have a lot less variables, and now we can go ahead and maybe try direct evaluation. If you apply that limit to this top, you end up with just that constant, negative 3. Applying it in the inside, we end up then with the limit as x goes to infinity of the square root of 1. Well, that's just that constant 1, minus, when we apply it to this guy as well, we end up with negative 3 over something really huge. Well, that's going to be approaching that limit of 0. Plus 1. Simplifying things now, we end up with negative 3 on top still, divided by the square root of 1 minus 0 is just the square root of 1. Square root of 1 is just 1. Plus 1. So it looks like we end up with negative 3 halves coming out to be that limit. Alright. So for this example, example 10, we actually had to do a little bit of a combination of things. We had to multiply by a conjugate. We had to do a little bit of FFU, apply various properties with limits, and then finally get the correct limit, negative 3 halves. But again, though, that is example 10 from our 1.5 number 2 set of notes.